Scamp, the Stanford Climbing and Aerial Maneuvering Platform, a robot capable of flying, perching, climbing, recovering from failure, and taking off outdoors using only onboard sensing and computation. At Stanford, we are interested in quadrotors because they can go places where people and terrestrial robots can't, like over this rubble from an earthquake. However, most quadrotors only have enough battery to sustain a few minutes of flight time. If we look at this picture again, we notice that there aren't a lot of good places to land. There are, however, a lot of clean vertical surfaces available for perching. If we enable our robots to perch, they can stay around longer, perhaps measuring aftershocks or setting up a temporary communications network. Once on the wall, it's useful to be able to reposition the robot accurately, for example by moving to the edge of the building to get better reception. Climbing is a more reliable way to accomplish this than taking off and reperching, especially when the weather turns windy. To perch, Scamp flies until its tail contacts the wall. Unlike previous quadrotor perching strategies, which usually take place in carefully controlled laboratory environments, Scamp does not use a motion capture system or off-board computational resources, so it must detect the impact by using its onboard accelerometers. It responds by turning its rotors on at maximum. The tail acts as a pivot, forcing the robot into the correct orientation. The rotors then adhere the robot to the wall aerodynamically until the vibrations from impact are dissipated and its feet have found a good grip. The rotors can then be turned off and Scamp can start to climb. This mechanically assisted approach to perching is effective in a wide range of outdoor situations. Scamp climbs by alternating loads between its 2 feet. The feet attach to bumps and pits on the wall using tiny metal spikes referred to as microspines. These attach when pulled down against the foothold and release when tension is removed. A conventional climbing robot doesn't have to carry the extra weight of a flying vehicle as it climbs. However, if such a robot misses a step and detaches from the wall, the results are usually suboptimal. On the other hand, if Scamp misses a step and starts to fall, it detects the drop in vertical acceleration and turns its rotors on briefly. This returns it to the wall where it can re-engage with the surface and resume climbing. When Scamp is ready to take off, it deploys a takeoff spine. Without this takeoff spine, Scamp's rotors would keep the robot stuck to the climbing surface, unable to rotate without reversing thrust. Transferring load to this spine applies a mechanical moment that rotates Scamp away from the wall and allows it to fly away.